So hey everyone, welcome back to the channel. I hope you guys are doing extremely well. One more problem in the graph series, which is the eventual safe states. What is the problem state? The problem states are given a directed graph of V vertices and E edges, and the graph is a zero-based indexing graph. A node is a terminal node if there are no outgoing edges. So there should be incoming, there might be incoming edges, but there should be no outgoing edges. Then we call that node as a terminal node. A node is a safe node if every possible, very, very important point, if every possible path starting from that node leads to a terminal node. Okay, now you need to return me an array containing all the safe nodes of the graph. The answer should be sorted in a ascending order. So what does the question state? So this is the given example. They're asking you, out of this, which are the safe nodes? That's what you need to figure out. What is a safe node? Every path, very important. Every path ends up at a terminal node. Ends up at which node? A terminal node. What is a terminal node? No outgoing edges, or you can say out degree of that node is 0. So in this video, I'll be solving this using the cycle detection technique. And in the next video, I'll be solving this using the BFS or the topo sort technique. So in this video, you need to be knowing about cycle detection in an undirected graph. If you haven't seen, you can go back like I think 3 or 4 videos in the series, you'll get that video. So out degree has to be 0. So can I say this guy has one outgoing edge? So this is definitely not a terminal node. Can I say this has no outgoing edge? I can. And can I say this is a terminal node for me? I can. So the first terminal node I can spot is 6. Do you spot any other terminal nodes? Yes, you do. If you see 5 has incoming but no outgoing. So I spotted one more terminal, which is 5. Do I spot any further terminal nodes? I do not. I do not, because everyone has an incoming and an outgoing edge as well. So let's start with 0. Let's figure out the first path. 1, 3. So it redirects me back to 0, not to any of the terminal nodes. So 0 cannot be a part, or 0 cannot be called a safe node. Let's try out with 1. 1 goes to 3, 3 goes to 0, 0 comes back to 1. So the 1 can also not be part of a safe node because it comes back to himself, or it doesn't, like all the paths do not end up at the terminal node. Let's check out 2. 2 has only one path. If you carefully see, 2 has only one path, and that ends up at 5. 2 has only one path that ends up at 5. So can I see this? Yes, can I see this? That 2 is a safe node. I can definitely see that 2 is a safe node. So 2 is a safe node. Let's check out for 3. 3. One of your paths is definitely ending up at the terminal nodes, but are all the paths? Let's check. 3 has one more path like this, and like this, which ends up at the 3 himself. So I can definitely say 3 cannot be a part of it. Can I have 4 as a part of it? Yes, it does end up at a terminal node 5. So 4 can also be a part of my safe node, right? Let's check out for 5. 5 is himself a terminal node, which means it's a safe node. So 5 is a safe node. Let's check out for 6. Itself a terminal node, so a safe node. So I can say this is the array in the sorting order which you have to return as an answer. So you have to figure out all the paths, and if all of the paths like end up at a terminal node, then you say that okay, that guy is definitely a safe node. So the question is very straightforward. Give me all the safe nodes present in a graph. So do you remember the cycle detection technique where we detected a cycle? So can I say, by observing this particular example, we did figure out that all the possible paths are going to end up somewhere. But if they return back to themselves, like there was 1, 3, 0, right? These 3 were the part of the cycle, and they can never be safe nodes. So something to observe. Anyone who's a part of a cycle can never be a safe node. So imagine if I have a 7 which is pointing to 1. Will 7 be a safe node? No. Why? Because 7 can have a path through the same cycle and end back at not a safe node. or not a terminal node. So what you can say is everyone who's a part of a cycle, you carefully observe, everyone who's a part of a cycle, everyone who's connected to the cycle. You can say everyone who's a part of a cycle and everyone who's connected to the cycle will never be safe nodes. And if you look at this is not having any incoming edges to the cycle, no incoming edges to the cycle. Thereby, it will always end up at terminal nodes. If there's a cycle and anyone who is connected to that incoming edges, so it will turn back on that stuff. So you cannot end up at a terminal node. So a slight observation we have noticed is anyone who's a part of the cycle, anyone who is a part of the cycle cannot be a safe node, and anyone that leads to a cycle, anyone that leads to a cycle cannot be. So I have figured out two ways. Apart from them, everyone else can be a safe node. I can definitely say that, right? So the whole problem can be easily solved by figuring out which guys are a part of a cycle and which guys are incoming to the cycle. That is what we need to figure out. Once you figure that out, I think we should be able to solve this problem very, very easily. So as of now, you know both the points, right? So we have already learned how to detect a cycle using the DFS technique. And if you do not know, please go back and watch it. And over there, we used a couple of arrays. One is the visited and one is the path visited, right? That is what we used. So we're going to do the same thing and we will run the same thing on this particular algorithm and we will see how can we figure out which is a cycle and which nodes are approaching the cycle. So we've learned cycle detection in the previous videos, right? And over there we used a couple of concepts. One is the visited and the other one is the path visited. Now over here we are going to apply the same concept and we are going to determine which are the safe nodes. So as of now for this particular graph, what you can do is you can draw the corresponding adjacency list. So this is how the corresponding adjacency list will look for this particular graph. So what we will do is, if you remember, we had a couple of visited arrays. So we will create both the visited arrays and assign them with zeros. So let's create both of them. Okay, so as of now, what I've done is I've created the adjacency list as well as I've made the visited array and the path visited array as well. So remember, all of these are assigned with zeros. So let's start the DFS calls. Again, since this can have multiple components, we will start the DFS in the standard way where we write I equal to 0 and then go for V and then we say not visited. Then we call the DFS. Remember this? So that's what we will do. The very basic standard way if there are multiple components. So which is the first one? It will go from 0. So let's start from 0. So you're starting from 0. This is where we are. So we will start the DFS call from 0. So let's start the call from 0. The moment you are at 0, what you will say is, okay, hey, listen, unless and until this call gets completed, unless and until this call gets completed, then only I'll call it as a safe node. And if this call gets a cycle anywhere in the path, I will not call this as a safe node. Got it? So let's start. So DFS of 0 says, hey, listen, I'm visited and I'm path visited as well. I'm visited and I'm path visited as well. Done. Next, it goes to the adjacent, which is DFS of 1, right? This is the adjacent node. This is the adjacent node. Goes to it. And as of now, says visited and path visited. 1 will now go to 2. And when it goes to 2, it says visited and path visited. 2 will now go to 3. So when it goes to 3, it again says it as visited and path visited. Remember this. Starts from here, goes here, goes here. Now it has two options. Either it can, from 3, it has two options. Either it can go to 5, either it can go to 4. So 3 goes and checks who's the first in the adjacency list. So the first it finds is 4. So it will go to 4. Remember this, it will go to 4 and then it will come back and probably go to 5. But that will be done in the later stage when the recursion is complete. Recursion classes, guys. So DFS 3 to DFS 4. So we will go for 4. 4 is visited, path visited as well. Next, 4 will go to whom? 4 will go to 6. So let's go to 6. DFS of 6. Again, it will mark 6 as visited and path visited as well. Now 6. It's a very important point. 6 is pointing to 7. 6 is pointing to 7. So it will call for 7. It will call for 7. and it will mark it as visited and path visited. Visited and path visited. Now, when you go to 7, it states, hey, I do not have anyone. I do not have anyone to further call DFS. So I'm like, did I get a cycle? No. We actually reached an end. We started our journey from here and we reached an end. Can I say every node in this is a safe node? Because you started a journey, but wait, there's one more part to be checked. Fine, we'll check it afterwards. But as of now, can I say from 6, there's one outgoing edge which ends at 7. And 7 is the terminal node where I'm standing at. So from 7, there cannot be any further DFS call. So can I say 7 is definitely a safe node? I can say it's a terminal. So what I'll do is, I'll just mark 7. You can use any map or a third array to just keep a mark, which is a check. So I say everything for 7 is done. No further DFS calls. So this is a safe node. Marked it as true, right? What's the next thing that we will do? What we will do is, okay, we've marked it as true. Next we come back. So let's come back. Now 6 says, I had a call for 7 and I ended. I do not have any further calls. Why? 6 only had 7 to go. Fine. DFS is over for 6. No further calls. This guy is also a safe node. Mark it. And remember, when you are returning, the path visit will go as 0. So now return to 4. Now 4 says, I do not have any further calls. I just had for 6 and I did it. I'm back. 4 doesn't have any DFS calls. 4 is also a safe node. So mark it as true. Oh, why am I going up? Mark it as true. And at the same time, make sure 4's path visit is done because 4 will now go back. So now 3, which went, cannot call it as a safe node. Cannot call it as a safe node as of now. Why? Because there's one more path which he has to explore. What does safe node means? All the paths should end up at terminal node. Over here 3 states, one path ends at a terminal node. I have one more part to figure out, does it end at a terminal node? I have to figure that out, right? So that is what we will do. We'll start from 6 now. Sorry, 5 now. So we'll go to 5 and we'll say path visited. Now 5 goes to 6. 5 goes to 6 because 5's next node is 6. But the moment you go to 6, you actually say, hey, wait. 6 is already visited. It got visited in this direction. And if 6 is already visited and I did not get any cycle. 6 is visited, but 6 is not path visited. It's not in the same path. It went in this path, now it's this other path. It's not in the same path. It's definitely not a cycle. And if 6 has been checked and we did not get a cycle, I will no more go and check for 6. And I'll be like, fine, I don't need to check for 6. So I don't need to do a call because 6 has already been checked. If you carefully see, 6 has already been checked and it did not get a cycle. So I will not go because 6 is definitely not a cycle. Why? Because it was in a different path and this is in a different path. 6 is definitely not a cycle. Because if it was a cycle, it would have gone like this. So it is not a cycle. And if it is not a cycle, can 5 do any further DFS calls apart from 6? No. So I'll say 5 is a safe node. And I'll mark 5 as unvisited and I'll go back. Now 3, explore this path. Can I say for 3, it explored both the paths, which eventually means it is a safe node. So I'll mark 3 also as a safe node and I'll now go back. Going back, make sure this is 0. 2 says, I'm also a safe node. So 2 marks itself and goes back. 1 says, I'm also a safe node, marks itself and goes back. 0 says, I explored all my paths. I'm also a safe node, marks it as 0 and goes back. Everyone, the path has been traversed. We did not get a cycle because this path does not have a cycle and everyone ends at 7. If you see, everyone ends at 7. So thereby, all of these nodes can be called as a safe node, right? So everyone done. Now this will change to 1, to 2, to 3, to 4, and it finds everyone is visited, which means they have been checked. There's no need to check again. They have been checked. So what I will do is, I'll now go to 8, and that's when we find it as unvisited. We will go to 8, and that is when we find it as unvisited. So what I'll do is I'll call a DFS for 8 now. So I'll just quickly raise this up because the next call will go for 8, right? So as of now, we have a DFS call for 8. So let's start the DFS for 8 now. So I start the DFS for 8. When you start it for 8, you mark them as visited and path visited, right? 8 has a couple of them, 1 and 9. So 1 and 9. So as of now, can I see this? 8 goes to 1, right? But will you go to 1? That's my question. Will the 8 call a DFS for 1? No. Why? So when 8 tries to go to 1, it says, hey, listen, I am already visited. I am already visited and I'm not path visited, which means I'm not a part of a cycle, or I'm not someone who gets into a cycle. Because if this guy was a part of a cycle, it would have been visited and path visited as well. Got it? It's not a part of a cycle. Because if you'd have encountered a cycle like this, the moment you encountered cycle, I would have returned. So the path visited for this guy would have also been 1, because anytime you get a cycle, you break and return. You do not reset the path visit. You only reset the path visit if and only if you did not get a cycle. Got it? Cycle detection video. So 8 states 1. You just visited. You did not get a cycle. So fine. This path is safe. I'll not call it, but this path is safe. I still have a path to explore, which is DFS of 9. Let's explore. So I go to 9 and I say, fine, visited, path visited. 9 says, I go to DFS of 10. 10 says, okay, visited, path visited. 10 says, the next guy that I have is 8. And that guy is saying, visited, path visited, which means false. So this guy cannot be a safe node, because 10 encountered an 8. Cycle cannot be safe. Thereby, it doesn't remarks itself as 0. It just goes back. You just return. The moment you get a cycle, you return. Do not reset. 9 says, you got a cycle. 10 got a cycle. Return. 8 says, you guys got a cycle. I'll return. No one unmarked themselves. So all of them are marked as visited and path visited. The thing that I was explaining. Everyone returned and none of them were safe nodes. Perfect. So we're done with this. Next, this will go to like 8, 9, 10. Now it's time for 11. At the moment you try for 11, see what will happen. 11 says I have a 9. The next one you try to go to 11's neighbor, which is 9, it says I'm visited and I'm path visited, which means I got a cycle. That's why I'm still path visited. Because someone returned. Someone did not unmark me. Thereby, this is also not safe node. Eventually, you'd have marked all the safe nodes and you can just store them. Very simple, very straightforward. Okay. So guys, I hope you understood the explanation. Now, the moment I'll start coding this, you'll see that this sticks into your head in a much better way. So I'll go to the detector cycle in a directed graph. I'll go to the summations and I'll pick the DFS code from there. So this was the code. If you remember, this was the DFS that I wrote. So I'll just pick up that and I'll paste it here. That's the first thing that I'll do. The next thing I'll do is I'll just pick up the internal thing for cycle check. Okay. So once you've pasted it, it's very important to analyze that you need to return an vector or a list as an answer. So probably you can just store it as safe nodes. Right. And we need to keep a mark which are the safe nodes. So just make sure they are marked. Okay. Now something very important over here. We do not break whenever we get a cycle, because we need to continue all the DFS calls. Remember this. We need to do all the DFS calls because we need to check for all the nodes. So it's not like you get a cycle and you break out. Do not do that over here. You need to check for all the possible nodes. Okay. All the possible unvisited nodes rather. So that's a small thing that you'll do. At the end of the day, you'll say, okay, let's quickly have a check for all the nodes. And something like, if the check comes out to be 1, then I'll put them into the safe nodes. We will see how we mark safe nodes. And then I'll return the safe nodes. Very simple and easy. Now, the question is, how does check work? So in order to do that, let's carry check as well. over here and over here as well, and pass it over here as well. So what did I tell you? That if the DFS is successfully completed for a node, you always say it as safe node, because if there is a cycle, it will always break out either here or either here. If there is a cycle, it will always break out either here or either on this portion. That is for sure. And if there is no cycle, then it will explore all the adjacent paths over on this for loop. It will explore all the adjacent paths over the for loop. And if it reaches the line number 31, it means it did not find a cycle. So you can say that it is true. So whenever you just enter, just make sure whenever you enter this guy, just make sure you see it as 0. Perfect. Now, whenever I get a cycle, it means for this particular node, on this IT, I got a cycle. So this node definitely cannot be a part of it. So safe nodes. So what you'll do is you just take the return node inside it, and right before this, you will say this node cannot be a safe node. No way. This is not required because you're initializing it, but still I want to explain you. If there is a cycle, it cannot be. Similarly, if it is a cycle, this guy cannot be. If it is a cycle, this guy cannot be, because it tried to explore a path of IT, it found the cycle, so it cannot be. And if it explored all the paths, then you say yes. This is the minor change that you needed to do on the cycle detection, and it does work fine. So that is the reason I say you that have your concepts so strong that you can modify it in whatever way you like, and you can always submit your codes. So let's discuss the space complexity. We're using 3 arrays, and it might take like 3n, but we can do this in a single array as well if you try to maintain counters. But then I'll not go that way. I'll keep it very simple, because this is what industry requires. Industry doesn't require like doing it in a one array. They require something which is understandable. So this is code quality in interviews. Do not go for a single array where you do 0, 1, 2, 3, 4 and certain stuffs, because that is not code quality. That is where the interviewer might give you lesser number of points. Yes, you can state that, like in interview, always state this approach. And then you can tell the interviewer that maybe I can optimize this to a single array in the space complexity by keeping like a counter 0, 1, 2, 3, 4, certain stuffs. You can try that out definitely by yourself. But that is something which you should not propose at the first stage, because the code quality goes down, the readability goes very, very down. What about the space complexity? It's the same what DFS takes. I'm not going to discuss this any further. So that should be it for this problem. So in the next video, I'll be solving this using the topo sort method. So guys, I hope you have understood this problem and the entire code. So just in case you did, please make sure you like this video. And if you haven't checked out our DP series and the HD sheet, what are you doing? The links are in the description. Please make sure you check them out. And if you haven't subscribed to our channel, it is a very, very earnest request that please do consider subscribing to us. Because that is the only thing that keeps you motivated to make these kind of content. And with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.